received a request to talk about some IXL problems. I do want to point out that in case y'all didn't realize this, that you can draw on IXL. So you just select the little pencils down here and you can change which one you're using, red or black, or highlight, or erase. So I'll be drawing on IXL. So basically when we're talking about negative exponents, we're basically saying it's just division because exponents are fast multiplication, and the idea behind a negative exponent is that this is actually division. So we can actually change this one to 12 squared times 1 over 12 to the 6th power. And so now we can see that we can just simplify this as 12 squared over 12 to the 6th power. Okay, so that's one way that we can simplify it. But we see we're supposed to choose all of the expressions that are equivalent to 12 squared times 10 to the negative 6th power, 12 to the negative 6th power. This option is not on there. So let's go through problem by problem. Using the multiplication rule, whenever you're multiplying with like bases, you add those exponents. So we could do 12 to the 2 plus negative 6, which would give us 12 to the negative 4th power. So that option's not up here. So we keep going. Well, 12 to the negative 4th power, that's a negative exponent, so we can actually rewrite that as 1 over 12 to the positive 4th power. So that makes our second option here one of our answers. We look a little further. 1 over negative 4 cannot be an answer because 1 over 12 to the positive 4 was an answer. Negative 12 can't be an answer because the only way we would get negative 12, and this is a wrong way to do it, is to multiply them. And we don't multiply the exponents when it's multiplication. We add them. So this would be 12 to the negative 4th power, not to the negative 12 power. And honestly, I really think that's the only answer choice that works on here. Let's try it out. Great. And so then we keep going. So select all expressions that are equivalent. So on this one, we have 8 to the 4th power times 5 to the 4th power. If you notice, all of these answers have 40 in them. That's because they have the same exponent, which means we can rewrite this as 8 times 5 risen to the 4th power. We can only do this because they have the same exponent. And then we can do 8 times 5 and get 40 to the 4th power. So that leaves us with the first one. And then I look across, it can't be 16. The only way they could get 16 is if they multiplied those exponents, but that's not what we would do here. We would do as I said in this one. This is not we're not going to multiply our exponents. 40 to the 8th power is saying that you multiplied and added the exponents. And again, we're not going to add the exponents here because these are different bases. Our bases are different. We're not going to do 8 times 5. We can only rewrite it like this because they had the same exponent. Basically, you're saying 8 times 8 times 8 times 8. And 5 times 5 times 5 times 5. Writing out in expanded form, and then kind of rearranging them 8 times 5, and then 8 times 5, and then 8 times 5, and then 8 times 5. Using the commutative property rearrange, we see that we have 1, 2, 3, 4 groups of 8 times 5. So that's 8 times 5 to the 4th power. So that one right there to the 8th power is not going to work. But let's look at this last one. 1 over 40 to the negative 4th power. Is that equivalent to 40 to the positive 4th power? Well, it is. If you have a negative exponent in the denominator, I like to think of it as unhappy. It does not like where it is. So if we move it to the top, it becomes positive, it becomes happy, because it wants to be multiplication, but right now it's shown as division, but it wants to be multiplication. So we fix that, by making it positive in this example. Hit submit. And that is our answer. Keep going. This is a similar problem to the last one. They have the same exponent. I'll rewrite it as 1 as 8 times 2 to the 6th power, so that's going to be 16 to the 6th power. So that's our first one. And it looks like the rest are not going to work. 1 over 16 to the 6th power is actually 16 to the negative 6th power. Again, talk about those negative exponents. So it cannot be the second answer because we did not have a negative 6 here, we had a positive 6. So this does not equal 1 over 16 to the 6th power. Those are not equivalent. To the 36th power here, they multiplied the exponents. We're not doing that here. And we're not going to add the exponents, so it cannot be that last one. Again, we do not have like bases. This is an 8 and a 2. I have 6 8s and 6 2s. I don't have 36 16s. There are not 36 16s here. There are only 6 16s. And if you want, you can write it out like I did on the last one, the long way. Every time if you wish, if you want to take the time to do it until you're better at it. Oh, that's a 2. Where's my erase? I have 6 2s. One more. Okay, and I'll change colors for, so 8 and 2. That's going to be an 8 times 2. And then another 8 and a 2. It's going to be another 8 times 2. And if you keep going, you're going to end up with 6 groups of 8 times 2. So that's where we get 8 times 2 to the 6th power. Because this is a pair, those go together, and those go together. So it ends up being 8 times 2, which is why we get the 16, and it's to the 6th power. So that's our only answer. Hit submit. Got it. This one right here, we've got 5 to the negative 6th power risen to the 4th power. Okay. And so in this situation, we have a power risen to a power. This is saying I have 4 copies of 5 to the negative 6th power. Erase that. So this is saying if we want to do this the long way, 5 to the negative 6 times 5 to the negative 6 times 5 to the negative 6 times 5 to the negative 6 4 times. And then we would add these exponents. We have 4 of them though, so it would be easier for us to just do 4 times negative 6. We're going to get the same thing as if we added all this together, negative 24. So we can think this more accurately as 5 to the negative 24th power. We don't see 5 to the negative 24th power, but we do see 1 over 5 to the 24th power. So that is one of our answers. And that's it. Good. And so we can keep going. This one works the same way as the multiplication problems. I have a fraction, 6 squared over 2 squared. Okay, they have the same exponent. They have the same exponent as 2. So that means I can rewrite this as 6 over 2 squared. This only works because they have the same exponent. And then I can just do the division on the inside. 6 divided by 2 will give me 3 squared, which is 9. And then we say, okay, which of these are equivalent? Well, I see 3 squared. 3 to the 0 is 1. 1 over 3 squared is 1 over 9. 1 over 9, not 9. 3 to the 0 power is 1, and then 3 to the 6 power over 3 squared. Well, if we look at that one a little harder, see if we can get 9 out of that. 3 to the 6 power over 3 cubed, we would subtract 3 to the 6 minus 3. Well, that's 3 cubed, which is 27. So this is not an answer. So it's just 3 squared. That's the only one that works. And honestly, a big part of this is trying different ways. Also, don't forget that you can watch a tutorial. And my advice on these videos, if you think he's talking too slow, speed him up. 2 times 2. Make him talk faster. You'll get used to it, or you can do 1 times 0.5 or 1.25 just to make him go a little faster, and you'll be amazed at what you can get used to. Alright, I hope you'll have a great day. And this one right here is that one. Yeah. And this one. To the 0 power, because you would multiply those exponents. 7 times 0 is 0. So this is just 2 to the 0 power, which is 1. And anything to the 0 power is 1. So if we look here, 2 to the 8th over 2 to the 8th is 2 to the 8 minus 8, which is 2 to the 0, which is, hey look, I put a 1 there by accident. Let me hit submit and see. Yep. Boom. Yep, you'll have a great day.